Okay, let us play a game where you need to find a queen card in the deck of these five cards. So, how will you find that queen card? You will randomly select any one of these cards. You will see it. If it is not a queen card, you will keep it aside. Like that, you will repeat the same process until you find the queen card. Right? See, I found my queen card. So, this is the exact way how our modern classical computers used to solve any problem. But when it comes to quantum computers, these quantum computers find the right queen card in a single move. No matter there are 10 cards, 100 cards, even a billion cards. Also, these quantum computers find the queen card in a single trial. It may sounds like science fiction, right? But it is not. This is the quantum computation. So, let me take you into the world of quantum computation. Before talking about quantum computers, why do we need these quantum computers? Before explaining that, let me explain how classical computers work. These classical computers basically consist of a small tiny switches called as transistors. These transistors are responsible to do calculations in normal computers. So these transistors just on and off the electrical signals that goes into the computer in computer system. So by using of these transistors, our now classical computers will solve any kind of problems. So when we decrease the size of these transistors, the computational speed of our classical computer will automatically increase. So that's why many companies are trying to decrease the size of these transistors to increase the speed of their computers. Like that, they from past many years, these companies are trying to decrease the size of these transistors drastically there, so that the recently invented transistor size is of 7 nanometer. When we compare this from any real world entity like our red blood cell is of 7000 nanometer, and the recently invented transistor is 7 nanometer. So this transistor is 1000 times smaller than the red blood cell. So these transistors are becoming so size of these transistors are becoming so less that where their size further cannot be decreased. So that's why there is not that much growth in the computer industry when we compare to past 10 to 15 years. So to increase the speed of these computers and to solve the complex problems, we need a new technology. We need a new way of computing. That computational method is quantum computing. So these quantum computers are so fast that to explain that recently Google invented its own quantum computer chip named as Willow. This Willow chip solved a problem in 5 minutes. In 5 minutes, that most advanced supercomputer of nowadays will take 7 septillion years to solve that particular problem. 7 septillion years means 500 trillion times older than our universe. You can see how fast this quantum computer is. So, from where this much power is coming to quantum computers? These quantum computers can process multiple possibilities to solve a problem in a single step. I think you may not get it, right? So to explain this, let me explain a main quantum physics principle that is working behind these quantum computers. The principle name is quantum superposition. This quantum superposition principle states that any subatomic particle can exist in both states two different states at a single time. To explain clearly, let us take a coin. When you flip this coin, while the coin is in air, you can't say that whether the coin is in head state or tail state. In air, this coin exists in two different states at a single time. This is exactly what superposition means. Superposition means existing of a particle in two different states at a single time. So, how this superposition can help quantum computer to solve problem? To explain that, if you take a normal computer which uses bits to to solve any problems, so these bits are nothing but 0 or 1. Like classical computers use bits, these quantum computers use qubits instead of bits. So these bits can exist only in one state, 0 state or 1 state. But these qubits can exist in 0 state, 1 state, and both 0 and 1 state at a single time. So, so to explain it more clearly, if you take a 2-bit classical computer, it can exist in 4 different states: 0, 0, 0, 1, 1, 0, 1, 1. But it can exist only in single state at a single time. But when you take a 2-qubit quantum computer, it can exist in 4 different states: 0, 0, 1, 0, 1, 1, 1, 0, all 4 different states at a single time. So this is where the quantum computer gets power. So to explain it more clearly, if you take a rat and maze problem where you have 100 ways to enter into a maze, but there is only one way to get out of that maze. When we given a classical computer this problem, it will check each and every possibility to get out of that trick. It will check first possibility. If it is not leading to that exit, it will come back. It will check another possibilities to get out of that page. But it will check only single possibility at a single time. But when we take this quantum computer, this as quantum computer have a power to exist in multiple states at a single time. So if you take a 2-bit quantum computer, it can enter into a maze in 4 different nodes at a single time. So this is what quantum computer is different from classical computer. So if you just increase the bits of this quantum computer from 2 bits to some 8 bits, then it can exist in 16 states at a single time. Like that, if you increase the qubits of this quantum computer to 100, this quantum computer can exist in 2 to the power of 100 states at a single time. It means if you keep 100 zeros after 2, we will get some value. Now that value, that much states a quantum computer can exist in a single step. So that's why that's how a quantum superposition principle helps a quantum computer to solve a complex problem in a very fast way. So I think you have understand how these quantum computers get this much of power to solve complex problems, right? So how these quantum computers will revolutionize our modern day science and solve modern problems. So so when we take a medicine making or making of vaccine, we need to check multiple possibilities. We need to do trial and error method to find the right vaccine to a disease. This is like there are so many ways, so many possibilities to find a right vaccine, but there is only correct way to find that correct vaccine. Here where the quantum computers comes and solve the problem very quickly. However, as I said before, these quantum computers have power to exist in multiple states in a single time. This so by using this principle, it will check some multiple possibilities which in which a vaccine can be made at a single time and finds a right possibility which leads to a finding of correct vaccine to any problem. Not only medical industry, it also it also helps in cracking complex encryption passwords. Like if you take a RSA to 2048 encryption password, normal computers will take 8 billion years to solve that problem, but quantum computers can solve that encryption in just 8 minutes. So you can see how fast these quantum computers are. Not only in encryption and medicine, it also quantum computers also can be used to find to understand black holes and even dark matter, the dark energy, which are one of the unsolved mysteries in our universe. So, based on these quantum computers, we can easily simulate a black holes and another galaxies, and also you can find multiple ways to reach into another planets in our solar system. So after computing all that ways, a quantum computer can find a right way in which we can reach a particular planet in a universe in a very fast way. So like that, quantum computers will going to revolutionize many industries like medicine industry, physics, astrophysics, and also medicines, and also so many. It will impact so many industries when these quantum computers actually come into play. But but uh, but these quantum computers are not that much developed now. So these quantum computers are in such a stage that where our classical computers used to be in 1960s, 1970s. These quantum computers are there in very beginning stage of development. So these quantum computers, as of now, these quantum computers won't replace classical computers at time, but in future these quantum computers can solve a complex problem, and it will completely change the way how we look into in our world, how we look our world. So this is all about quantum computers. Thank you.